Today is the flyweight pattern. It's about saving memory. If your app creates millions of similar objects, like particles in a game or characters in a text editor, the flyweight can reduce memory usage dramatically by sharing common data. Let me show you how. Imagine you're building a game. When a bullet hits something, you create particles. Tiny dots with a position, speed, color, and a sprite image. Each explosion creates hundreds of particles. A big battle might have 1,000,000 of them. Here's the problem. Class particle with X, Y, speed X, and speedy as unique numbers. Then we have color and sprite. The color is the same for many particles, and the sprite is huge data. The sprite is the same for every red particle, every blue particle, every green particle. But you're storing it 1,000,000 separate times. 1,000,000 particles times one heavy sprite each equals a memory disaster. The flyweight splits object data into two categories. First, intrinsic state. Data that doesn't change and can be shared. The sprite image, the color, this lives in the flyweight object and is stored once. Second, extrinsic state. Data unique to each object. Position, speed. This stays in each individual particle. You extract the shared data into a separate flyweight object. All similar particles reference that one shared copy instead of storing their own. Think of letters in a book. The letter E appears thousands of times. But we don't store a separate font image for each occurrence. We store one image for E, and every occurrence just points to it. That's the flyweight. Let's build this. The flyweight stores shared data, class particle type containing color and sprite. These are read-only. This sprite is heavy data, but now it's stored only once within this type. The particle stores only unique data, plus a reference, X, Y, speeds, and a type field. This is a reference to shared data, not a copy. Every particle uses the same type object. The draw method then just reaches into that shared type to get the sprite for rendering. A factory manages flyweights and ensures reuse. We start with a private map called types. The getType method checks. Do we already have a red particle type? If yes, reuse it. If not, it creates a new one and caches it in the map for future requests. Now see the savings. We create 1,000,000 particles using 3 random colors, red, blue, and green. Each particle gets its shared type from the factory. All red particles share the same type object. 1,000,000 particles. But the heavy sprite data exists only 3 times. It's that efficient. Each particle holds a tiny reference instead of a heavy copy. Enormous memory savings. Use flyweight when your app creates huge numbers of similar objects eating up memory. Real examples: text rendering with shared glyph data, game engines with tiles and particles, and browser DOM optimization. The trade-off: added complexity and CPU time for lookups. You trade memory for a bit of computation. That's the flyweight. Share and save memory. I hope this helps your architecture. Next is the last structural pattern, the proxy, which puts a stand-in in front of the real object. See you there.